We have a MacBook Pro. It's a 16 inches, which is going to be A2141. The description they have here randomly turns on then goes off. That's wrong. That was, I suppose, that was the initial state of the device. Right now it doesn't turn on. So, as you guys know, for no power devices, we first ascertain the state of it before we blow power to it. So let's quickly take the back cover out. Okay, see what you're looking at. Uh, Battery screw has been taken out. So I suppose this was when the assessment was being carried out. Okay, so what we're going to do is just quickly check for short and the 5-volt line, 2.5-volt line, and the PPBUS line. So we're going to be using, we'll leave the small meter dedicated for the for continuity mode, and then we can use this one for our PPBUS reading for voltage. So this is going to be for voltage as well as diode mode, and then this we just leave this for continuity measurement. So let's see what we have. Let's open up the board view. This is going to be an 80.01700, 01700. So our PPBUS is going to be measured at the dual fuses here, which is F7000 and F7001. You see where it says PPBUS. Those fuses are on the PPBUS line. Let us see if we have any short on the PPBUS. And you know, commonly when it comes to the 16 inches, the common issue with this ones are usually fried SSDs, and sometimes you also get and obviously, when that happens, you will get a case of you get a short on the PPBUS line, even though the issue might not be a PPBUS directly on the PPBUS line. And also sometimes you also get a field cap, and then yeah. So these are the common issues on your 16 inches if you're not dealing with liquid damage or drop damage. So let's see, it's black blue probe on ground and then red probe on our PPBUS line. And yes, that is a big short on our PPBUS line. So we are now going to just go ahead and take the board out. So let's take the board out and let's hope that this is not a case of a damaged NAND, because if that is the case, it means this is going to take longer in terms of the repair, and then also it would then also mean that there will be no clients and data after the repair. So usually what we do is we swap out some of the SSDs that we had swapped out from previous repairs. So if it is the case of if it is the case of the SSD failure, then it will mean that we have to replace the SSD. And then this actually looks like a 1 terabyte configuration here. So and then also what we do is usually we get an identical logic board, and then also with identical SSD configuration, and then we do a direct swap. So let's quickly take the board out, and let's really wish that this is not a case of a damaged NAND. And yeah, let me take it off from there. So the A2141 was the last 14 inches, the first and the last 14 inches that Apple did, and that was only 26. That was only 2019, and then in 2021, that was when they had the non-touch bar, which is the 16 inches with the M1 as well as the 16 inches now with the M2, and then refreshed with the 16 inches M3. So this was the only 16 inches they had with a touch bar. And then they had two configurations, the i7 and the i9s. Okay, screws are all out. Now let's disconnect our cables. So we have these two left. You now need a T6. This was also the first time Apple introduced the physical angle sensor, which is this one here. So the and then they carry that over on the newer designs. Hmm. So with the older 16 inches, the angle sensor is universal. So what that means is if I take this screen now and then transfer it into a different board, it will work without me having to use the angle sensor from that board. So with newer machines, with the M1s, and then so you will have to use the angle sensor that was paired to that board on the screen that you're transferring. So if you use a different angle sensor, you will lose your sleep signal. Do you understand? So, but with the older design, which is here on this particular one, if you are replacing the screen, you don't have to worry about having to use the angle sensor of that particular board. You can just any of the angle sensor you can grab. A 16, obviously, there has to be a 16 inches angle sensor that will do the work. So that's something to also note. So if you happen to be buying the 16 inches, the M1s or the M2s, make sure if you're buying the screen, make sure you also get, make sure you have, you transfer the angle sensor. Otherwise, what will happen is you will lose the sleep function. So which would then mean practically when you close the lid, the machine would not know that the lid is closed, and then your machine will still be, the display will still be on. So we have more cables. Okay, the board is out. Let's put the shell on the side. Okay. So this is the common issue that we really experience, or that we really find with the 15-inch designs. So whether it's the A1707, whether it is the A1990 and the A7120, A7121, what am I saying? A2141. with the case of the 16 inches is that you have a build-up of dust. You have a build-up of dust on both sides, and then with a bit of moisture that would cause especially your components to corrode, and especially the capacitors on both sides. So when that happens, that is usually what would cause components to fail. And so this can be avoided if this machine goes through a periodic form of service. Say, for example, after, like, depending on the type of environment you use the device, and then this, and you see you have the accumulation, and obviously, so the more the fan works, and then you see the dust here, so it tends to settle on the side. So if this can be, say, if this service can be done, say, once in say once in 2 years, depending on the usage, once in 2 years. The first time when you buy the machine from the box, so you can probably give it, say, 2 3 years, and then you do a service. But afterwards, it would be good if you do like say, once in a year type of service, which will keep that will keep this from happening, and then that will obviously also prevent the board from failing in this manner, because oftentimes this is what we find with the 16 inches, the 15 inches, A1990, and then the A1707. And this is really a common way they fail, and also with the case of the common failures of the C9081 and the A1990s. Is it C9081? Yeah. Okay, so that's also how the cap on the PPBUS line fails. An extension of PPBUS line, which is not directly on the PPBUS line, but it was a PPBUS line through a current sensor resistor, which then generates PPBUS voltage line to the SS regulator. So yeah, this is really the common failure that we experience on the 15G. So let's test the board out and see what component has failed and why we are having a short on our board. We're really hoping that this is just going to be a cap, so that we like a failed cap, and then we don't have to really yeah. So we have two sides to concentrate on. We have the right and then the left. So on the right side, all of the components seem to be okay, and obviously we will be concentrating on this section here because of PPBUS. So if we see this angle here, let's flip the board to the other side. So if we flip the board to the other side, so the angle will be, okay, this will be your PPBUS. And then this side, sometimes you also get a field cap here, but that will be like your 2.5 volt line for the NAND. But in this case, we are having a short on our PPBUS. And then also, okay, that's we can just, yeah, that will be some other time. So yeah, so right now let's just concentrate on the short we're having on the PPBUS. So here we don't have anything. We don't have anything here. And then on this side, this cap is not looking good. This one here, this, and that is sitting on, let's see, yeah, but okay, so that's the cap that is not looking good. That's not a PPBUS. That's not a cap that is sitting on the PPBUS line. So that's a 2.5 volt line. Okay, okay, let's see, do we have a short on our 2.5 volt line? Let's see. Okay, we don't have a short on our 2.5 volt line. Let's go back to our PPBUS just to confirm again. We still do have a short there. Okay, so what we are, okay, let's see on this side here, do we have a short here? Okay, so that's good. We don't seem to have a short on 2.5 volt line. Let's see, what is that? Okay, Okay, so now we just need to, although this seemed to be fine, but we are going to, even though we don't have a short here, it would be better to have that cap replaced, because even if it's not failed now, chances of it fading in future, it's going to be quite ripe. So what you're going to do, it's we see that this section here seems to be okay. Now we just need to work our way down to where the PPBUS short is coming from. So let's start. Let's just confirm again. Yes, we still have a short on our PPBUS. So let's now what we want to do is we want to kind of break it down. So if we come here, we this is our PPBUS. Yeah. Okay. Let's restart that. So let's do a quick breakdown. PPBUS is here. Now, on one side, we have one side go to the battery, and then on that side, what is connected there is you have a MOSFET, which is Q7040, and then you have a bunch of capacitors, and then on the other side, you have where PPBUS is going into the board. Now, first of all, we want to confirm that this has nothing to do with the CPU line. So we flip the board to the other side, and then here, where it says R5990, that it's basically going to be a bridge between the PPBUS. You see where here it says PPBUS underscore G3H, yeah, underscore G3H. But on the other side, it says PPBUS underscore HS underscore GPU. Now, we now want to see that we don't have, so we are going to remove this current sensor resistor because that is basically a bridge of your PPBUS line going to your GPU. And then let's see, and then on the other side of the board, see on the other side of the board, we have, okay, a bunch of capacitors there. And then that will be for your speakers, yeah, okay. And then here, let's see, okay, that's fine. Okay, so what we can do is we can start by removing, and then this side will be for your CPU. So R5400 is going to be for your CPU, and then the other one is going to be for your GPU. So what we want to do is, if we have a short on this side of the board, if we have a short on this side of the board, for example, the short is also going to be present here because of R5400. If we have a short on this side of the board, the short is also going to be present here because of R5400. So what we are going to do is we are going to remove R5400 to help us narrow down if the issue is on this side or on the other side. So let's start by removing. Oftentimes you don't find the issue to be on the battery side. So we're not really going to worry about having to remove, say, your R7060. And then I'm just thinking we shouldn't even worry about removing the two fuses. So let's start by removing R5400. That will help us narrow down if our CPU is the side of the CPU is free from the short. So let's remove. It's okay. So this is that resistor here. That's a current sensing resistor, by the way. Okay, so that is out. So what we want to do now is we want to see if so we want to see if we have where the short is. Is it still on the PPBUS side or on the side of the CPU? So our black probe is on ground, and then our red probe, we can check here. Okay, so this tells us that we don't have a short on our CPU, the side of the CPU. So the side of the CPU is this side. You see, we don't have a short there, and then this. Now the next one, the thing to do now is do the same thing on the GPU side, which is going to be this one here. So let's also remove it, and then see if let's hope that it's also not a short coming from the GPU. Okay, so and this also helps in case of when you are when you inject voltage onto the board. It also helps by removing the bridge between your main PPBUS line and your CPU as well as your GPU, because you don't want to send voltage to your GPU or your CPU. So this is also I mean, in case of if you also intend to inject voltage onto your boards to basically narrow down your short. Okay, so let's now check that. Let's check the two sides now. So this side will be the GPU side, and this will be the CPU side. No, and that would be our main PPBUS line. Okay, that doesn't look good. It seems it's the GPU. Let's see. Yeah, it's coming from the section of the GPU. That's not good. That's not good. Okay, now yeah, so we see now the short is gone on both sides. We no longer have a short on the PPBUS. So the issue itself was not the short was not actually on the PPBUS line itself, but was present on the PPBUS line because of the current sensor resistor from the GPU. So let's put back the current sensor resistor for the CPU, and yeah. Okay, so that is done. Now we okay, so let's go back to the other side of the board, and that is going to be the other side of the board. Where are you? Where are you? So that's R5990. So one side is your PPBUS, and then the other side is your GPU. Okay, so we are now, so our issue is going to be one of the many points here, and then we're really hoping that it's a case of a component and not a GPU itself, because on the other side wait, okay, yeah, yeah, it's really hope, and that may also explain why the device was randomly going off before it finally died. So so now we know that we have to look at this section of the board. Let's remove this, and I really hope that this is not a case of a GPU chip itself. So you understand how we are doing, the yeah. You see, that helps us to narrow down which region the short is constituted on, instead of having to check go by component and just okay, a heat sink is out. Here's our beautiful GPU. Nothing really stands out on the GPU. GPU looks okay. Any of the MOSFETs look, let's see. Okay. Okay, so on the side of the GPU, so these are all of the components that we are hoping. Um, so all of this here, here, and this here, this here, this, and then this, and then on the other side, you have 1, 2, 3, 4, and then you have 1, 2, 3, and then you have 1. Yes. Okay. So let's see this side of the board. Let's see which is going to be, wait, um this side, yeah, this side. So let's open that up and see if anything looks out of place. Okay, that looks good. That looks good. And then let's now check the side, which is this side here. And looks good at about this side here. Also looks good. Okay, we're not seeing anything that stands out as yet. And then on the other side, let's see, let's check this section first, which is this section. It looks good, looks good, looks good. Okay, so that, let me see, nah, that's fine. It's crystal, it's fine. So anything stands out? No cap. If we don't find anything, then we may have to inject voltage. Okay. Uh, yeah, I would have really loved it to be an issue on the PPBUS line without the CPU or the GPU being involved. Cause yeah. Okay, so let's just inject voltage to it. And we really hope that this is not going to be a GPU issue, like a failed GPU itself. That would be really good. It's, Then we attach one to ground. So the idea is we run power to it, and whatever component it's making causing our short would get warm, and yeah, really hope this is not a case of a GPU failure. Really hope it's not a case of a GPU failure. Okay, so let's see what power. Okay, and we gradually increase the voltage. The see what gets warm. It's not good. The GPU died. It's warming up. Nah, it's not. This is not good. Yeah, it's warming up. And then this is we're also getting. Let's see. Yeah, it is warming up. It's warming up. This GPU die is warming up. Ah, yeah. It's okay. So let's see. Yeah, it's this is a typical case of inna lillahi wa inna ilayhi raji'un. Yeah, it is. It is heating up. It is heating up. Ah, yeah. What was that? Yeah. Okay, let's do that. Okay. Issue it's it didn't. 'Tis unfortunately a case of a GPU, and so I guess what yeah, it's just let's inject voltage again and try again for one last time. That's for ground. Okay. Let's make sure we don't short it out. Let's try again. Mm, GPU is getting hot. Feel it? It's unfortunate. So yeah, PPBUS went to your GPU and yeah, and if you increase it, it will get even yeah. It's quite unfortunate. Yeah. Um. So yeah, it's quite unfortunate. Our GPU is gone. Uh, okay. This is going to be a case of a GPU replacement. Uh, okay, guys. Yeah, this is going to be a case of a GPU replacement. Unfortunately, yeah. Let's put back the current sensor resistor. Usman, what we are doing here doesn't concern you. What? It doesn't concern you. Ah, okay. Oh, okay. I think that's it's actually there. No, I was looking for that.
So, what, what do you need to do if the client let's say to replace a GPU? Does he need to reprogram, just replace chip from one board to another?
Yeah, you don't have to reprogram it. Okay. Yeah, we'll inform the client and then we'll take it up from there. Thank you guys. I will see you guys in the next one.